Welcome to the Computing There I Was podcast. I am your host, Richie B. Today I am speaking to Steve FORTRAN. Steve had an extensive career at three major tech companies, IBM, then Bell Labs, and finally Google. Hope you enjoyed the conversation. Hi, welcome to Computing There I Was podcast. I am your host, Richie B. Today I'm speaking to Steve FORTRAN. Hi, Steve. How are you?
I'm doing quite well, thank you.
That's good to hear. So I always ask, my very first question is always the same, is how did you get started with computing and stuff?
Okay, sure. So I went to high school in State College, Pennsylvania, which is the home of Penn State University. My father was a professor. It's actually a pretty good high school, I guess, being a university town. One time they offered a computer programming course, so I took it. So this was teaching you FORTRAN.
Okay.
And they had a key punch or a couple of key punches in the back of the classroom. So what you did was, to do whatever the homework was, you would go back to the key punch and get your deck out of cards. I assume you know what cards are.
Yes.
And then, we would submit it. The teacher would put a rubber band around your deck, take it down to the computer center. Computer center at that time was an IBM 1130. It was, I guess, primarily for use for administrative purposes in the school, but we were allowed to use it as students. So then whoever worked there would put the deck in the machine and read it and give you back the printout, and maybe it worked, maybe it didn't. So the next day you'd get back and then do it again. So anyway, introduction to programming was FORTRAN on card decks.
What kind of problems did you do? I mean, how
No,
advanced
I don't actually remember any of the homework problems, but I got the bright idea. I was a chess player at the time. So I said, I'll write a chess program. So I talked this over with my teacher, and I said, well, there's two main parts. One is the part which generates all the possible moves in the position. And the other part was the one that figured out the best one. And the teacher said, well, I can sort of see the first part, but I don't know what the second part's going to be interesting. Well, it was interesting. I did some kind of depths, multiply search. I think maybe I did 2 or 3 ply. So what I would say about the program is it would spot a mate in one, and it knew most of the legal moves in chess. It probably didn't get some of the really weird corner cases. But the big problem was, well, it's a little hard to play chess when you're doing it on a card deck and you wait a day to get your opponent's move. Didn't play very well in the end anyway.
How long was that program?
How long was it? Oh, good question.
How many cards?
It fit in a box. So I think a box was 2,000 cards. It was probably about 1,000 lines. And there were probably a few comments in there.
Right.
So,
interesting.
But, representing a chessboard in FORTRAN was kind of a challenge.
Right. Yeah, my first programs were in FORTRAN as well in physics, but I remember when for one of the homework problems, somebody did a program and it was 100 cards, and I was amazed that it was that long.
So after high school, I went to Penn State, in part because the tuition was $65 a quarter because my father was a professor.
Right.
So I majored in computer science. I took like most of the computer science courses. The problem as an undergraduate there was, well, they had an IBM mainframe, System 360, and it was the same kind of deal where you put your program on the cards, and you gave it to the operator. And if you were lucky, you'd get it back in an hour or two. Otherwise, it'd be the next day. So I do remember many long nights at the computer center, fixing bugs and rerunning. But I probably might not have gone into computing, except that I found a sort of out-of-the-way computer on campus. It was in the EE department. It was a hybrid computer. So there was a PDB-10 as the digital part, and then there was an analog computer, which was not very well known nowadays, but basically it had op amps,
Uh-huh.
operational
Right.
amplifiers, and you could integrate with those, and then you'd have resistor networks. And there were some D to A converters and A to D converters. So in principle, you could run analog simulations, which were governed by the digital computer, the PDP-10. The interesting thing about with, I don't think I ever saw anybody actually using it. You had to program it by this big patch panel where you put cables in from one amp to a resistor or whatever.
Mhm.
And I don't think I ever saw them. They were detachable, so everybody could have their own private one. But anyway, I got really involved in the computing side of that. Managed to get a job there. So my first job was as the operator, and my job was to mount deck tapes. So
Oh,
you may remember what deck tapes are. They're
yes. Uh-huh.
sort of 4-inch little magnetic tapes. They're sort of the mass storage of the day, or the personalized mass storage of the day. But in modern terms, they stored somewhat less than a megabyte. So actually smaller than a floppy disk, I think. But for the time, they were actually very advanced because they had a directory structure. So you could
Uh-huh.
read and write files. You could have multiple files on the tape, and you could go to a particular block on the tape and rewrite that one. So, people would come in, they'd be working on a program, I'd mount it for them, and then they would, do whatever they did. Now, the
Right.
PDP-10 at the time had 80,000, 80K words, 36-bit words of memory, so something, 300, 400K bytes
Right.
in modern terms. They were restricted. I tried to remember exactly what the restriction was, but they couldn't use more than 10K, maybe 15K words at any given time. So in the early days, it was a time sharing system. There were maybe 4 Model 33 teletypes. So maybe you could get 3 or 4 people working at once. And if they were all good, then you'd see the tape spinning on the computer mainframe, which was always entertaining. It looked like a science fiction set or something.
Yeah, yeah. When I worked on PDP-11s, we had tapes, and I would stand in front of the tape and speak with German accent, and
Yeah.
they laughed at me at the institute.
Yeah. But anyway, this was a very different environment from the computer science comp center, which was
Mhm.
batch and cards. This was
Mhm.
time sharing and, wonderful Model 33 keyboard teletypes where you could type while it was typing, and it would all keep it straight except for what got printed out. But
Right.
so we often felt we were fighting with the teletype.
So Deck 10 was I guess the PDP-10 was predecessor of the Deck 20, right?
Yeah.
Yeah.
There were several versions of the Deck 10, and we had the basic one. Eventually, we got a disk, which at the time was 5 megabytes, which, which wasn't enough to give everybody any disk space, but you could at least use it for storing the operating system and compilers and things like that. So that
Right.
made life a bit easier. So yeah, one of the things I did was write an early mail program. It's probably overstating what it was, but it
Mhm.
was just a way of sending a message to somebody else who had an account on the machine. But it
So what
didn't
did
it didn't go outside of the computer. It was
Right. But I guess you stored it on a disk then, right?
yeah. So you had to have a little bit of disk, and so not everybody could use it.
So what kind of courses were you taking, in computer science? What sort of
All of them. So it was a lot of programming courses.
Right.
I'm not sure. I think I took, let's see, FORTRAN, which I didn't really need to take, and PL1. There was
Okay.
assembly language course, probably an operating system course. I think I wanted to take the COBOL course, and my advisor talked me out of it as saying that's kind of a waste of time, which it was accurate. I also took a lot of math courses, so I was really sort of a CS math double major. Then there was required courses like physics and stuff like that.
So your final degree was in computer science?
It was computer science, yeah.
Oh,
But my sort of intellectual life was in this out of the way computer in the double E department.
that's kind of cool.
That's really where I learned everything I know about computing. I was eventually became sort of the system programmer, so I was writing PDP-10 assembly language
Mhm.
and modifying or trying to debug the operating system when it failed, that sort of thing.
Yeah, I actually once fixed a bug in the device with a tape driver for on the PDP-11 for RSX11M because I worked for a bank and I wound up writing a device driver, which is kind of funny. Did you go to graduate school? Or?
Yeah. So after Penn State, I went to Cornell as a Ph.D. student. So I was there, became much less of a programmer and much more of a researcher. So I was indoctrinated with the Cornell computer science theory is good attitude. So wrote papers, wrote a PhD thesis eventually. That's when I was introduced to UNIX. So right at about this time, computer science department had a UNIX computer. Mm-hmm. And so we were able to timeshare that. Again, it was probably 4 or 5 terminals altogether. But that was such a big difference from the computer science batch-oriented 360. Right. It was nice. I learned enough about Unix to appreciate how much cleaner it was than the TOPS 10 DEC operating system, which had evolved in assembly language over time. It's hard to remember how awful it was actually in terms of the internal details. But yeah.
Yeah, my first job, I was working, as a COBOL/assembler programmer using punch cards and stuff. But then I discovered that there was an department in the bank that was getting PDP-11s and they're going to have terminals. Mm-hmm. So naturally, I transferred there. So what was your thesis on? Anything interesting?
Well, it was very interesting because it got me my degree. Well, let's see, you really want to know? So it was, you know what P and NP are, right? So
not really.
Oh, well, okay. So NP is this class of problems in computer science, which you can solve by guessing, but you can't solve by searching because it takes too long.
Right.
So that was the very early days. And there was also these known results in logic, which said some things are just not provable within, mathematics, essentially.
Right.
So the question was this an example of that?
Oh, okay.
The P versus NP question. We didn't figure that out. Otherwise, I'd be really famous. But we did do something, advisor and I came up with something which was independent and vaguely computer science related. But so it was sort of a combination of computer science theory and logic.
So after Cornell?
After Cornell, I went to IBM. And I had a couple offers at that point. I hadn't really decided whether I wanted to go to university and become a professor or go to industry and become an industrial researcher. I didn't really understand what the difference was, to be honest. Right. But then IBM came up with a very attractive offer, which was roughly twice what the professorship was. So perhaps foolishly, I decided that was a good reason to go to IBM.
Did you work up in Westchester? Or?
Yeah, so I was at the Yorktown Heights facility, which, if you've ever seen it, it's a beautiful building.
I've been there once or twice.
Yeah. It's actually a terrible place to work because you're in an office with no windows. And if you want to see something outside, then you have to walk down the corridor. But then there's really no place to hang out. So you have to go back to your office. So there, the first project I worked on was a verification project where we wanted to verify the correctness of microcode. So there was an implementation of a 360 or similar machine using a lower level microcode. Right. Unfortunately, it was well beyond the technology of the time, so it kind of crashed and burned. I didn't start that. I sort of jumped in towards the end of it, and that wasn't good. Then I worked on, we'd call it, in modern terminology, it would be called a programming environment or like Eclipse. So it was a syntax-directed text editor for PL1. Well, actually, so at IBM, PL1 was king. None of this seemed sense. Yeah. So it was actually, there was a subset of PL1 called PL.8, which was supposed to be the good 80% of PL1, which is kind of a contradiction in terms, but anyway.
Well, my very first programming language was PLC, which was the Cornell version of PL1.
Yeah, that came a little later. Yeah. So the compiler group at IBM was very good. And so PL8 was sort of a language to drive compiler research. And so it did a very good job of optimizing code. So somebody did a comparison between PL.8 optimized code and C code written by a experienced, knowledgeable programmer. And it was basically a toss-up, if I remember correctly. But it was nobody within IBM was interested in in C or Unix or anything like that.
Right.
So the big technical achievement when I it was at IBM was they had virtualized the operating system. So
Right.
this was VM 360.
Right.
So their idea of time sharing was you got your own personal virtual 360. And of course, there wasn't any networking. So it was yours, and you could essentially interact at the console and give, operator instructions. I remember they somehow hacked together a version of email. So the way you read your email was to type cards, and that would load your virtualized card reader, and then you could get your deck of cards. And so the notion of having common file systems was, no, we don't do that.
Right.
They had something called temporary disks where you could own a piece of a disk for a while and then give it somebody else, but you have to sort of explicitly pass it back and forth. So as a computing environment, I didn't like it very much, particularly after coming from Unix, where things were a lot more sensible.
How was the work culture? Did you have to wear like a blue suit and a blue tie, all that kind of stuff?
No, it was pretty informal.
I guess the research center would be like that.
Yeah, I didn't have a whole lot of interaction with, the non-research, the business unit parts.
Right.
It was, except for the fact that it was kind of ignoring what was happening in the outside world in computer science, it was a good place. But I mean, I don't remember exactly what other projects were. I told you about I guess for a while I went over to the math center, which was much more a research oriented place, and stayed there for a year. But at that point, I was fed up with IBM and left. So then I went to Bell. Go ahead.
No, so yeah, I was going to ask you, where did you go?
Oh, okay. So then I went to Bell Labs, and I ended up staying there for 32 years. So I guess I liked it.
Which one? At the Homedale?
This was one in Murray Hill. So this was the central research facility. So that was an interesting place. Just to give you a big picture, I was in what was called Area 11. So that meant essentially fundamental research, and so there was physics was big at the time. So there were any number of Nobel Prize winners, either already awarded or about to be awarded. So very strong physics. There was a math center. I was in the computer science center, which in the internal naming was 1127. It was also known as the UNIX lab. So this was where UNIX was invented. So Ken Thompson, Dennis Ritchie, Brian Kernighan, other people you may or may not have heard of, like Doug McElroy, were the people around. So this was an interesting place. There was no direction, particularly. You were hired and then basically told, do whatever you want. If you need some budget for something, let us know, and we'll see if we can work it out. You want to travel? Yeah, go ahead. Don't worry about it. Just do what you want to do. And this was fun. And you look around, and the group that I was in, it was, there was the Unix people, but then there were just lots and lots of other people, numerical analysts, compiler people, language people, not very much software engineering, but except for the Unix group. But anyway, it was a little bit intimidating. There was
I would imagine so, yeah.
Once a year, you had to give what was known as show and tell. So you have to get up in front of 60 of your closest formidable computer scientists and talk for an hour about what you were doing. So people had nervous breakdowns. Almost. I mean, I don't think anybody really did, but that part of it was a very stressful. I actually very rarely talked to my manager. I mean, might talk to him at lunch, but not in any technical way. The management was very lightweight. Once a year, you wrote something called an I am great, which was a description of what you'd done for the last year. And you were very carefully instructed that it couldn't be small font and it had to fit on one page. And so you gave that to the management. Then they went off in a huddle, and a week later, that was called Form 1. They came back with Form 2, which was known as abstract merit. which was, oh, you did this well, you could do that a little better, again, I don't think I ever had anything that was longer than half a page. And then a few weeks after that, you'd get what was called Form 2, which you'd get what was called concrete merit, which was what your raise was, or your bonus.
Okay.
Anyway, the management was just impressively lightweight.
That's kind of cool. I mean, it's considering all kinds of things that were invented at Bell Labs, I guess it worked. So what kind of stuff did you work on?
Right. So for the first, 10 years or so, I did pretty much computer science research. So my specialty was something called computational geometry, which you can think of as coming up with algorithms that work with geometric objects, so points, planes, solids. If you do a Wikipedia search for Fortran's algorithm, you'll find something, which was one of the things I did. That's probably the best known thing by, in quote, the mass media, the mass population that I did.
Oh, good. I'll put a link to it in the notes.
Yeah. So that went on for a while, and then lots of things were happening. So I went to Bell Labs just around the time of divestiture, which meant that AT&T split into the long distance company, the RBox, the local companies, and so Bell Labs was part of AT&T, the long distance company. So the AT&T higher management was not really cognizant of what was happening in the computer industry, and they thought that long distance telephone calls would continue to pay for AT&T for the indefinite future.
Right.
So there was some problems there. There were also issues where AT&T was trying to sell telephone equipment to the long distance company, but at the same time it was competing with them. So this was not a good the equipment part of AT&T was not very happy about this because they couldn't sell to. So then what was called trivestiture happened about 1996. That was when AT&T split into NCR, which was the company they had bought and then had to sell at a loss, Lucent, and AT&T, which was then purchased by Bell South. So anyway, there was a lot of, shall we say, upheaval in the telecom industry. So one of the things I did at one point was to implement an algorithm which did wireless propagation prediction. So inside of, a conference center or a building, this was using ray tracing. And at the time, the idea was that AT&T or Lucent would sell personal, essentially cordless phones, except for a company. So it was supposed to work over the building. Of course, it was quite expensive. I mean, these things were $100,000 or $1 million for the base station and the antennas and so forth. So it was very important to know where to put the antennas. So I was trying to solve the problem of how you design the wireless systems. In any event, that was quite interesting because it was quite successful. Well, it was technically quite successful, commercially not so much, but that's a different story. But it was well liked by the business unit side of the business. So all of a sudden I discovered that, if I want to double my salary, I have to do useful stuff. So I don't know whether my salary went up by a factor of 2, but it went up significantly as a result of that. So that was one thing that was happening. The other thing that was happening was, as I said, the telecom crunch. All of a sudden, things were pretty dire. So after, jumping ahead a little bit, at its peak, Lucent, which was then the owner of Bell Labs, was worth about $60 a share. And if you try to follow through what it's worth now, it's like maybe a quarter a share, 10 cents a share.
Yeah, I owned Lucent for a little while.
Yes, I had lots of capital losses because of Lucent stock. So then I did a lot of stuff which was much more, applied. So designing optical network. Go ahead.
No, I mean, this is late 90s. This is when internet
is probably post 2000. Yeah.
So the stuff that you were doing, did it involve the internet and stuff on networking in general?
No, I was never much of a networking person. Well, okay, so let's backtrack. You understand networking as internet, as IP, TCP/IP.
Well, there were other networks before then, yes.
Well, yeah, but you understand it as packet switching.
Yes.
Certainly until at least about 2000, Bell Labs and Lucent and whatever understood it as circuit switching. So setting up optical pipes, I worked on designing optical networks, which were so-called long haul. So an optical fiber, which would go across the country,
right,
transmit at, say, 10 gigabits per channel, 100 channels per fiber. But you could go from New York to LA with this kind of technology. So again, the issue was designing those things. Mm-hmm. So at the sort of layer 1, layer 2 level, I did a lot of networking. At what you think of as networking, I didn't do very much at all.
I did some, when I was first started working at a bank, we did lots of like point-to-point connections, with the old protocols, like, if you know, BiSync and things of that sort.
Yeah, I never got I was much more at the design level than the actual software stack level.
Yeah, we were building connections between banks and other financial networks and things. So, well, during all this stuff, did you have any interesting bug or war story about a particular problem that you?
Yeah, so let's go back to the PTP-10 days.
Okay.
I guess I was probably a little bit beyond the operator stage and more toward the system programmer stage, but the login program, you would type in your account number and your password, and it would not let you in. In fact, it would just crash. It would give you the equivalent of a core dump.
Right.
And then you try it again a few minutes later, and it would work fine. So it was this intermittent crash the login program was doing. So I probably spent, I don't know, a month. I mean, I was a student at the time, so it wasn't like full time.
Right.
But I eventually traced it down to a sequence of 3 machine instructions, which, if they were executed in a particular bank of memory, did not work correctly. And so the PTP-10 had 80,000 words, which was a 64,000 bank and a 16,000 bank. And if it was in the 16,000 bank, it didn't work. So it was kind of the luck of the draw is where the login program was sitting at that point. I don't really remember how I figured it out. I did a lot of, the equivalent of print statements.
Right.
But they were, anyway, I don't know. Anyway, once I told it to the hardware people, they were able to fix it pretty quickly. So, some timing issue or something like that. But yeah, that was probably the hardest bug I've ever found.
Interesting. Okay, so then you are at Bell Labs and all this stuff.
Yeah, so at Bell Labs, sort of post 2000, things were a little bit less freewheeling, shall we say. This was an era when the third Thursday of the month was kind of something you wanted to avoid because that's when the layoffs happen. So they would be, you'd hear debates about, well, shall we lay off people at the beginning of the year and then we only have to lay off, 5%, whereas if we wait until the middle of the year, then it's going to be 10% to make the budget. There was a lot of pushes to get external funding. So going to National Science Foundation or DARPA, we did manage to get one external funding, but that was very hard. Nobody wanted to give money to Bell Labs to do research, essentially, because they wanted to give it to the universities instead. And we weren't really set up to go to DARPA because that's big projects and a lot of sort of overhead, management overhead.
Right.
So that was one thing that was going on. The funding was always an issue. Oh, yeah. So at one point they decided that the building was, a third occupied. I don't know whether you know this building, but it's a huge building. It was like 2,000 people at the peak. It was maybe a quarter occupied, a third occupied. And they decided, well, we're paying a lot in heat and electricity, so it'd be better off to just tear it down and we'll recoup the cost of tearing it down in terms of maintenance costs in a year or two. So there was a period when go to lunch in the cafeteria and you look out and you see a backhoe ripping the building down, in particular in where my office used to be. So that actually lasted. It took them a long time to do that. That was like a year and a half of this kind of depressing, I continued to work there finding, I worked on call center software So the idea was, you call the call center and you have some script that they go through of trying to fix whatever your problem was. And
Right.
the idea was, well, we'll do machine learning to figure out what the best order is. I left before that ever actually, well, it never came to fruition while I was there. I think once I left, it just stopped.
Was it, actual machine learning as we thinking of it today, or?
Oh no, this was certainly not large language models and neural networks. This was much simpler things.
Maybe expert systems were a thing for a while.
Yeah, so this was, I forget the technology, the algorithmic technology exactly, but it was sort of like expert systems, except that you have this agent that you're trying to direct, and you have, at any given time, you have a set of options that you can choose to use, and you're trying to figure out which one will resolve the problem the most quickly. And the way you learn was, well, you have a bank of operators, you gets a lot of calls. So if you can record what they're doing and then apply the machine learning algorithm to optimize that. Problem was that their scripting language wasn't really set up to identify what the particular steps were that you needed to take in order to, what concrete action can you take in order to resolve the problem. So they had to sort of revamp the scripts and the language to make that much more explicit.
How long did you stay finally at Bell Labs?
Well, it was 32 years from 1983 to 2015.
Oh, wow.
Yeah. So it was at the time that I left Bell Labs, I'd had a pretty good career between IBM and Bell Labs itself.
Right.
But Google was around the corner.
Right.
And, a friend that suggested that it was a very good time to apply to Google. So I did, and got a very nice offer after 5 or 10 years of very minimal wages. Google was very attractive in terms of salary, but it was also very attractive for lots of other things. So when I was at Bell Labs towards the end, we would have, video conferences, department-wide or company or research-wide meetings. And since there are multiple locations, we tried to do video conferencing. And they had a specific person who would be in charge of setting up the meeting. And he would start half an hour before the meeting. And typically it would be half an hour into the meeting before it was actually set up. So video conferencing was like this black art that nobody understood. And then I went to Google, and it was like a science fiction set. What? You mean it just works? I can do it on my laptop? I mean, I can go to a room. I can do it from home. I can do it from China. It just works? What? How did this not possible? So Google was very impressive. It was very impressive in many, many ways. But that was the first thing that impressed me.
So which area did you work in? So you were in New York office, of course.
Yeah, I was in the New York office. I was working on local search, which means map search. So if you type the query something like vegetarian restaurants open Sunday, then we local search team would try to figure out how to answer that query and give you the appropriate kind of restaurants. So that was a lot of data which needs to be gathered. It was tons and tons of machine learning algorithms. And it was tons and tons of, industrial strength engineering to do that at scale with millions or billions of queries per day. So what I did was the search part of it, which was trying to optimize the answer. So, as an example of the kind of thing that I did, you might think you know what a vegetarian restaurant is.
Right.
And so the data we had suggested that Subway was a good vegetarian restaurant.
Ooh.
And I had a discussion with some of the other team members, and they defended it. One person was a vegetarian. Well, if I'm really in a pickle, Subway is a good place to go because they have a vegetarian sub.
Right.
And I said, I know there's this complicated way that queries are evaluated. Our raters think it's a terrible answer. So we did a little bit of a scientific experiment to try to understand, back up, I'm forgetting something. The way we figured out whether a restaurant was vegetarian or not was to use something called Google Guides. So if you signed up for this, then you agreed to answer questions about places that you went to.
Right.
So, for example, if you went to a restaurant, then you'd get the question, is this a vegetarian restaurant? Well, the way the question was asked is, does this restaurant have vegetarian options? So by that definition, Subway is a vegetarian restaurant.
Right.
It's just not what you would want to go to if you're a vegetarian. I mean, it wouldn't be your first choice. So we did a scientific experiment with lots of different questions. And the phrasing of the one that won was, would a vegetarian choose to go to this restaurant?
Oh.
And then Subway lost, of course, because you wouldn't choose to go there. If someplace has like an Indian restaurant, it probably has lots of vegetarian options, so you might choose to go that. So anyway, that was just a little thing, but that was the kind of thing of trying to get the data better, trying to get the algorithms better.
What language was this? Or this was all C++, I presume?
This was all C++, yeah. I forgot to mention that Bjarne was down the hall when I was at Bell Labs.
Oh.
So I was introduced to C++ at an early age and suffered through many incarnations of the language. And then I went to Google and realized I had to start over because Google rules were so specific.
Right. Yeah, first time I used C++ was when it still had single inheritance.
Oh, okay. I first used C++ when it was a preprocessor in front of C. So
right. Well, yeah, that's kind of what I used when I used it on an Amiga of all computers.
Mm-hmm.
There was an early version that somebody ported, the C front. So did you stay at in search all your time?
Yeah, I was at search for the whole time that I was at Google. The interesting thing about search and Google as a whole is there's a lot of learning curve. So it probably takes you, particularly for search, which the way I describe it is you've had thousands of very smart people working on it for a couple of decades. So there's a lot of complexity there. So it took a while to learn enough about the search stack to actually try to be productive and helpful. All the various tools for evaluating how the search stack was working. I was perfectly happy there. It was a nice combination of having an impact in the world. I mean, given, I would make improvements, and if it was a good day, it would be like a 0.1% improvement, which doesn't sound like very much, but if the denominator is 1 billion people, then the numerator is 1 million people. So you could do something which would give better results to 1 million people. And so that was the advantage of Google's scale.
Well, the scale also makes it a different problem. So the kind of silly analogy that I make, anybody can make breakfast, right? Scramble some eggs, make some coffee, and make a piece of toast. But making breakfast for 1 billion people in the same amount of time, it's a completely different problem.
Yeah. So again, I was not on that part of it, the sort of distributed computing infrastructure. Yeah, but that's a fair point.
But still, I mean, the people, who figure this out.
To use your analogy, I would make the breakfast a little bit better for those 1 billion people.
Any good debugging stories from Google?
Oh, gosh. No, the tools are so good. Joke, right. Yeah, it took me a long time to learn how to read the debugging output. So you'd get some cryptic error message, and then you'd have a, 10,000 line log of where one line of it told you what actually happened, that this file was unavailable or something like that. So I'm not sure that there's any specific debugging story, but the notion of debugging at scale at Google is challenging.
So did you, towards the end of your time at Google, did you get to use any of the AI tools that Google was building?
So the last year or so, we were doing large language models for internal projects. And that was interesting. I learned very well about hallucination. So we were trying to generate sort of snippets of information about places. And we had plenty of training data because we had plenty of examples of that. But what we didn't have was it took us a long time to figure out how to control hallucination and make the models not make up things when they didn't really know anything. Large language models have gotten much better at that, much better in minimizing that, although they still do to some extent. But yeah, that was definitely a challenge. the world has changed since I left. So large language models are much more heavily embedded within Google search, and they've gotten a lot better. And it's much more about prompt engineering than it is about what was then called fine tuning and distillation and so forth. So different technology. So yeah, I was at Google until, what did I say, 2022 or thereabouts. Mm-hmm. And that was the first round of tech layoffs, and I was one of the ones hit. So I figured I was old and well paid, so I was a good target. Yeah, I mean, it was sort of interesting that I survived, I don't know, 10 rounds of layoffs at Bell Labs, but then I got hit on the first round at Google.
Well, Google was interesting that way. I don't know how they decided who was laid off or not. I would have been happy to leave at that time as well.
Oh, the offer was generous. I mean, it ended up being close to a year's salary. I think people who got laid off afterward, it was much less generous. It was also, nobody in the first 3 levels of management even knew that it was happening. It was just came down as a fait accompli. So it was algorithmic on the basis of very limited information.
So what have you been doing since?
Not much. I've been worked 43 years, or something like that. So taking it easy. We do a lot of traveling.
Certainly that's enough of work.
Yeah. Well, actually, I looked around for another job after I was laid off, and I got a few nibbles, but it was very hard for me to figure out someplace that I actually wanted to work after having worked at Bell Labs and at Google. Everything else would be less exciting. Yeah, I didn't need to work because we had, saved up enough money. So it was like, well, I'm not really motivated to work.
You're not interested in teaching or mentoring students and things like that?
Yeah, yes, but it hasn't gelled. I thought about teaching at someplace in New York City, but the idea of taking the train and then teaching for 2 hours and then coming home and getting paid essentially train fare was, why?
So my last question is always, if somebody was who's starting in the field today, what kind of advice would you offer?
Yeah, so let's see. The first piece of advice might be, don't assume you know what you're going to do. Try lots of different things. Keep learning. If you're taking coursework in one area, take coursework, do something else, take other courses. If you're working one place, it's okay not to like it and to move elsewhere. I mean, my career was pretty static. Nowadays, it's a lot more dynamic. I think people work shorter, but I think that's good. So if you're getting bored, move on.
Right.
The second one is, nobody wants to hear, but learn how to communicate. So I think the biggest problem I've had with other people is how bad their communication skills are. Mm. And I'm not sure mine are all that good, but learning how to write well, learning how to, compose a message, know your audience, that can be very hard, but those are skills that will help you a lot. In terms of actually getting a job in the current job market, I have no idea.
Right. It's I sort of offer the same thing. I always tell people you have to learn to write well. And with the advent of ChatGPT and all that stuff, I think people are sort of hurting themselves if they avoid writing and they use ChatGPT or some such tool to write instead of doing it themselves, even if it's painful.
Well, Google Mail, Gmail, now has this option to correct what you wrote and to, quote, write it better, unquote. And sometimes it actually does write it better, and sometimes it just doesn't mean the same thing. It doesn't have quite all the nuances of understanding. So you have to understand what it is you're trying to say and say it well. That's what's hard, actually.
Well, the other thing is, people probably like to hear stuff in your own voice as opposed to generic generated stuff.
Correct.
Well, I guess that's kind of all I had for you. Thank you so much. You had a very interesting career. I mean, you've had like all the three big companies.
Yeah, one of the things I learned was, in a world with lots of monopolies, your personal life is a lot better inside the monopoly than outside it. Mm. So one thing I miss from Google days is just the keeping up with what's happening in the field, having access to computing resources, all that sort of stuff. Yes, I did go to all the monopolies. It wasn't intentional. I didn't start out by doing that. But.
Right. Do you keep up with what's going on in the field still at all?
Not very much. Basically, what I read in the paper and what I learn from talking to people. I've had a sufficiently varied career that there's no one area that I, focus on. So that makes it a little bit hard. I'm sort of more of a generalist. So certainly what's happening with large language models is interesting, and where that is going to go is very unclear.
Oh, I know what I wanted to ask you. So I think at Google you did some interviews of software engineers.
Yes.
Can you reveal one of your questions?
Sure. I think this was actually an internal question, and I'm sure it's been banned. But okay, you have an infinite chessboard, and you're given a knight, and you start at the origin 0, 0, and you want to get to something which is a parameter 14,3 or something like that. So what's the minimum number of knight moves it takes to get you from where you start to where you want to get to? So write a program to solve this problem.
I would have to think about that.
The discouraging thing about this is that I asked ChatGPT or Gemini or one of those things to do this, and it came back immediately with several of the possible solutions. And I told it, well, choose the first one and write code for that, and it did a perfect job. So I am a little worried that this kind of question is is very useful anymore, because ChatGPT can do it better than any of the people I interviewed could do.
There was a question that I used to ask when I worked at Bloomberg, which was to write recursive Fibonacci function, right? Which is pretty easy, and you expect everybody to be able to do it, and most people were able to do it. But then I would ask them what would happen if you call, this was written in C or C++. So I would ask them, what happens if I call your function with 10,000 as the parameter? And most people got the answer wrong, because everybody would jump right away to Stack Overflow. And so
it depends on what language you're programming in and what
right. But I mean, you can say, I asked them to estimate the size of the stack, and they had some issues. So, but the funny part is, I asked that question of ChatGPT earlier, and it could write the code, of course. But then when I asked it the follow-up question, it got it wrong. So it would try to convince me that the stack size was exponential growth, which it isn't. But
it depends on that's right. The stack size is not
stack size is linear. It's just in the depth of the calls, right? So it was kind of funny.
Yeah, assuming you did it in Python and you adjusted the stack size parameter so that the stack was big enough, which you could do, then the issue is that the numbers you're going to get are pretty big, and it might actually take a while to compute 10,000 factorial.
It's not 10,000 Fibonacci number, which is worse than factorial.
Okay, sorry.
Yeah. So it's the answer is really that it will take till the hit of the universe for the thing to finish. But anyway, all right, Steve. Thank you so much for talking to me.
All right, enjoy talking to you.
And to our listeners, come back next time. Thank you.